All right, so we're on page 9 of your review packet, and I just want to do a few problems with you just to hopefully refresh your memory before I turn you loose to review. So I'm going to start with problem number 1. This one's kind of interesting. They're telling us here that segment AB is 1 hash mark away from the center. And then they tell us that segment CD is also 1 hash mark away from the center. So if you had to guess, what do you think is true about segment AB and segment CD? They're both the same distance away from the center, so they're congruent. So all I have to do on that one is say that AB equals CD and then solve for X. So there wasn't much to do there. All right, anyone, are you guys solving it? Get an answer? Anyone getting close? Yeah, X equals 2. All right, so that helps you with that first part. Look at question 4, please. Now on this one, what kind of a segment do we call ZY? It goes from the center to the circle. Radius. What kind of segment do I call WZ? A tangent. And we have in our rules, a radius and a tangent have what relationship? Let me get out here. Tangent and the radius are perpendicular. So we put a right angle here. So in this picture, I have a right triangle. And which side is the hypotenuse? WY. So be careful that your hypotenuse goes in the right place. A squared plus B squared equals, we'll call that X squared. So just be careful. X is not always the hypotenuse, but whatever side is across from 90 is the hypotenuse. So from here, I'll let you grab a calculator and solve that one. Make sure we all can get the right answer there. Mm-hmm. And I'm going to do one later where X is not the hypotenuse, just so we can practice and see the difference. All right, I've heard a couple of people say 26. Anyone else feel good about 26? Awesome. So that's how you do that one. Yay. Okay, next up is number 5. Now on number 5, we did some like this in our practice page. There's a rule that says segment AB and segment BC have something special going on. Do you remember? Right here, let's get it not shiny. Tangents from a common point are congruent. So these two tangent lines are the same. So that means BC is 3. Now if I look at FD and CD, how big do you think CD is? 4. So for this one altogether, X is 7. So this was kind of like that page where you had to find the perimeter of the, like they connected these over here, and you had to find the perimeter. It was on page, 4 of the practice. So definitely on your test, 100% on your test. All right, let's look at number 7. Number 7, let me get in here. Number 7 looks a lot like this picture right here. I feel like I should take this out of the plastic so you can see it better. All right, so number 7 looks like this one. If 2 chords intersect inside, then AB equals CD. Please notice that means A times B, not A plus B. So on this one, I want to find out what BE equals. CE is 6. Oh, careful. CD is 16. This whole thing is 16. So how big is ED? 10. Be really careful there, trying to trick us. We're not going to fall for it. AE is 17, and BE I'm trying to find. So on this one, oh, so soon? Bye-bye. I'll post the video. You can watch if you want to. All right. So on this one, be careful. You're going to multiply the two numbers on the same segment. So I'm going to multiply 6 times 10. And then I'm going to multiply these two numbers because they're on the same segment. 17 times x. By the way, on your test, it's very important for you to show your work. This is showing work. Labeling the picture, writing an equation, that's showing work. If you circle true and you don't show any work, you don't get any credit for that. So you must show work. Who's got an answer to this? We solved that yet on our calculators? It's a decimal. What is it? 3.53? I think so. Anyone else? I did 60 divided by 17. Yep, 3.53. Any questions on that one? So that was, whenever you see that picture, use that rule. They intersect inside. Now let's go to the rules where they intersected outside. On the next page, let's take number 14. Notice on number 14, they intersect outside the circle. Which rule do you think number 14 looks like? The second one or the third one? I feel like an eye doctor. 2 or 3? Which is better? Which picture does this one look most like? Does it look like a secant and a secant? Or does it look like a secant and a tangent? Yeah, so it's secant, tangent. So this one we do outside times whole, and then the tangent piece that's by itself we do squared. So let's take a look. So this segment right here, what is the whole thing all put together? I'm going to write whole times outside. And the whole is where you add the parts together. So should I add 2 plus x plus 6? That's the whole thing. Okay, if you wanted to be fancy, what else could you call that? X plus 8. Wait, what?
Wouldn't it be like 2 times 2 plus x plus 6?
I was about to get there.
Oh.
Yeah. So the outside part was 2, and then the whole thing was adding all those pieces together. Now, when I do the other segment, LG, well, how big is the whole thing from L to G? 6? Yeah. That's hard to see. And then the outside part, also 6. So be sure you square it because the whole thing is the outside part. So 6 times 6. And then we solve. So if I'm doing the distributive property here, I've got 4 plus 2x plus 12 equals 36. I'll give you a minute to solve that. Aha. We getting somewhere? Braden says 10. Do you guys agree? Yeah, because I'm down to 2x equals 20. So yes, x is 10. Okay, work. I love to see all that work, especially the first equation that you started with the setup. That's the best one. That shows you understood the geometry. Okay, questions on that one? We're going to do 15. I can talk to you about 13, though. Let's do 15 first. So 15 is very much like 14. It's still whole times outside. How big is this whole thing from C to L? 4 plus x. How much is the outside piece? 4. So that's where I start. The whole thing added together times the outside piece. Segment NL, how big is the whole thing? 5 plus 7 is 12. And how much is the outside part? 5. So it's the outside part times the whole thing. And now we solve. Distributive property. When you're taking your test, don't be in a hurry. You've got plenty of time. Take your time so you don't make careless mistakes. We want to avoid careless mistakes. Aha, I see the answer. Anyone else see the answer? If 4x equals 44, Brady, what'd you get? 11. Okay, so far so good. All right, we've had a couple of requests to look at 13. Once we look at 13, you'll see, oh, I do know how to do that. Which one of these 3 pictures does number 13 look the most like? The top one?
Yeah.
Because they intersect inside. So it says I'm just going to do AB equals CD. So let's do that. This segment, what are the 2 pieces? 11 times 11. And then this segment, what are the 2 pieces? 5 and x. Ta-da! Not as bad as you thought. And I do want to talk about number 16 when you're done here. Who's got it? Max, what'd you get?
24.2.
24.2? I see some here. I hear some thumbs up. I see those thumbs. Yes, we got 24.2. So remember, show your work, and then you can get credit for your correct answer. Alrighty. Can we answer number 16? Might as well. Is HI tangent to circle G? If this is going to be tangent, what has to be true about HI and HG? It has to be a right angle. So that's what we're going to try to figure out. Is that a right angle? Question mark. Well, how do I figure out if that's a right angle? What theorem might I use? Pythagorean theorem. All I have to do is be sure which one should I put for C. Yeah, the biggest one should always be the C. So I'm going to check it. Does 9 squared plus 40 squared really equal 41 squared? Try it in your calculator. Let me know. Is this really a right triangle?
Sorry.
What's that?
Is it either yes or no?
It's either yes or no.
Yeah.
And here's the work. I'm just going to square them. Are they equal? Does 81 plus 1,600 equal 1,681? Yeah. So the answer is yes. In order for it to be a tangent, that needed to be a right angle, and it was, because the Pythagorean theorem worked. Okie doke. All righty.